Boom. Hello and welcome back to Calculus 1 for one last time.
Yeah! Boo!
Okay. We'll have to edit the intro. So, yeah. Second part, new sub. We are going to discuss the U-substitution when we have limits of integration. So we did indefinite integrals so far. And we are going to take a look at U-substitution with limits now. So last time we said look for function derivative pair, put function as u, the derivative will remain as a du, and it should turn into a basic integral which you can solve quickly. So now we are going to do these transformations for problems that have limits, and the new part is that you will have to either change the limits when you change your variable along together, right? Or you will have to solve the entire integral, ignore the limits, and then hopefully remember that you had limits, and then when you go back to original variable, use the original limits. I personally like to change the limits along the way because it helps immediately with, so you know, I don't forget to do it eventually, and it also helps with calculations. It's faster. So let's take a look at one of the introductory example. So very simple, integral 0 to 2, 2x over x squared plus 1 squared dx. We are looking for function derivative pair. What's u?
No, it's the bottom one. Oh, yes.
And then du is going to be 2x dx. Observe that we have 2x dx, so that's going to be du. So we are getting now the integral of u to the minus 2 du, right? X squared plus 1 is u, so we use squared. It's in denominator. It goes up as a negative 2. And here is the new part. This is what we are learning now. Change limits of integration. Your old limit was 0. So the bottom limit x1 was 0. So your u1 is going to be 0 squared plus 1 equals to 1. So we are using the u substitution, and we are plugging in each of these limits to compute the new u limits, and then we don't have to go back to x. We can just use u and be done with the problem. So now we have 2 squared plus 1, which is 5. So the old integral was 0 to 2 for x domain. The new integral is 1 through 5 for u domain. We quickly integrate this as negative 1 over u, right, because we add 1. And instead of putting plus c, we are computing it from 1 to 5. So that's going to be negative 1/5 minus negative 1 over 1, which is negative 1/5 plus 1, which is 4/5. So the entire procedure here was identical to what we did yesterday. We added whatever is in red, which is change of limits from x domain to u domain. And once you do that, you are able to solve the quickly. Let's see another example of this. Say you have Let's see what else we can do. All right, let's do smaller steps. So integral 0 to pi over 4 sine x over cosine squared x dx. All right, let's see what that gives us. Go. So you want me now to crush it, right?
Yeah, sorry. I didn't know it was on loud, sorry.
After you went through hell of finding it. What is u over here? Very good. And du is the derivative. Derivative of cosine is negative sine. And then we change limits. So x1 original limit was 0. We plug that into the cosine. We get that u1 is going to be cosine of 0, which is 1. So now, when we do our substitution, the lower limit is 1. We have, again, u to the negative 2 needs to be negative. Du, upper limit x2 was pi over 4. So u2 is cosine of pi over 4, which is root 2 over 2. So the upper limit is root 2 over 2, and the lower limit was 1. So now we will integrate this, and we will get now 1 over u computed from 1 to root 2 over 2, which is 1 over root 2 over 2 minus 1 over 1. This is 2 over root 2, and then we rationalize. We still have minus 1, which is equal to, this is root 2 minus 1. That's the exact answer. Now, yeah, you can get 0.41 if you want the decimals. No one cares, but the process that you are learning now is to change limits of integration. This is problem 52. Let's see what you can do. 0 to ln 4 e to the x divided by 3 plus 2e to the x dx. Guys, problems like this will be on a test in 2 days. What do we have over there? ln 4, the upper limit. 0 to ln 4. What's a u?
At the bottom, 3 plus 2e to the
What is the u?
2e to the x dx.
I don't have a 2. All right. Bottom limit U1 is what? We plug in 0 into the problem, into the substitution, and we get 5. Is that okay? So bottom limit gives us 5. U2, upper limit, 3 plus 2 e to the ln 4. E and ln will cancel. 2 times 4 is 8 plus 3, 11. Inside we have du over u. What is the integral of du over u? I asked you that yesterday. Hell yes, ln u. ln absolute value of u computed from 5 to 11. This is equal to 1/2, open parenthesis, ln 11 minus ln 5. Now, if you want to be really fancy here, you are going to put this ln together and say this is ln of 11 over 5. And then what you can do is you can take the half inside just to show off how boss you are. And do that. I use 2 properties of logs, which you should know. (43) Integral of -1 to 2 x squared e to the x cubed plus 1 dx. Protest, like it's democracy. The what?
I'm just messing. You'll see. We have it on video.
Well, that's why he needed his phone to do the video.
Yeah.
Oh, I got so much stuff in here. I can't even go through this. Dude, like everyone shut up. I'm trying to learn. Oh, are you showing him the back crack? You know what makes me practice that.
Oh, I thought you were practicing. I was waiting for the pump.
Oh my god. That's great. Oh my goodness, that's good. That's got jokes.
The level of trolling behind you guys. So, I thought the past years.
Yeah, I believe that. I'm like trolling. I'm like professor, the best professor I ever had.
Yeah, he's just trying to prove this.
No, seriously. Didn't I tell you that like 2 days or 3 days ago?
Yeah, you're making sure now.
Just back up on.
Yeah. What's the u sub over here?
X to the x cubed plus 1.
Very good. And du?
3x. 3x squared ds.
I don't have 3. So it's going to be 1/3. All right, what are the limits? U1.
U1 is it? You plug in 2 into U, which is 8.
It would just be
U1 is the lower limit.
Yeah, I meant U2.
So -1 cubed is plus 1? Okay, 0. How about the U2 upper limit?
That one's not right.
That would be 9. So the limits changed, as you can see, from -1 to 2 to 0 to 9, as we changed domain from x into u. So we have e to the u du, which is 1/3 e to the u computed from 0 to 9, which is 1/3 e to the 9 minus e to the 0, 1/3 e to the 9 minus 1/3. Or you can factor out 1/3, get e to the 9 minus 1, whatever. I don't want to call this grand finale, but it's out there. 0 to 1/4. X divided by the square root of 1 minus 16x squared dx. What should I put as u?
X squared.
Nope. 1 minus 16x squared. What's the u? So we are going to fix the constant there and have -1/32 integral. Now we have to change the limits. u1 is equal to 1 minus 16 times 0 squared, which is 1, and u2 is 1 minus 16 times 1/4 squared, which is 0. Now, what is interesting about this problem? Yeah, you see the limits are flipped. The bigger number is on the lower limit. Now, remember the theorem we had in 2 classes ago? We had the theorem that you can flip the limits and you lose the minus in front. So that's a really cool part. So this is u to the negative 1/2, because it will be 1 over root u du. And now we switch the limits, so we get 0 to 1, we u to the negative 1/2 du. Maybe I can in this step leave 1 over root u and then switch it in this one. So now we need to integrate 1 over 32. That's going to be u to the 1/2 divided by 1/2, computed from 0 to 1. Now this 1/2 goes as 2, makes this 1 over 16. Root u from 0 to 1, which is 1 over 16, square root of 1 minus square root of 0, which is 1/16. Maybe these limits over here I should put red, 0 and 1. And then swap limits A for B. So that's the new feature that you haven't seen before. So now this problem is tricky. It says integral x over x minus 2 dx, and they tell you the u sub because it's not intuitive. Try to see if you can figure it out now. So if u is x minus 2, what's du?
Yeah.
Dx. Du equal dx. Good. So now if we try to substitute, we see in the issue, right? The bottom is u, du is dx. We have this x extra. So what should we do? The trick is to solve from this substitution and plug it there. You are going to split 2 fractions now, simplify algebra, integrate each one independently. This process is called back substitution. It's rare, but it shows up. So now it's algebra. This is integral of u over u du plus integral of 2 over u du. So we have two integrals there, right? They break on the plus. The first integral is just integral of du plus, and the second integral you can kick 2 outside and have du over u. So the first integral is what? What's the integral of du? What's integral of du? Integral of 1 du, come on. So the first one is just 1 integral of 1 is u plus 2 ln u, and we bring back the original variable. So u was x minus 2. So we have x minus 2 plus 2 ln x minus 2 in absolute value plus c. So that one is called back substitution. It's tricky because you have to see that this x in the numerator was extra. But luckily we were able to deal with it. Sometimes when you have extra, you can't do this method. You have to use some other method. So now, I think that's I think that's it for this lecture. The next part is, that's it. So bye stream.